Example number 2 asks us in part A to differentiate the cosine of theta times sine squared theta. So we got a couple options here that we can do. What I'm going to use is a combination here of the product rule, okay, because I've got the product of two functions, and then over here I'm going to use the power rule in combination with the chain rule. So here's what we've got. When we take the derivative of this, okay, we write it like this: d theta of the function okay. Now what we're going to do is use our product rule. So the product rule says we take the derivative of the first times the second plus the derivative of the second times the first. So the derivative of cosine theta with respect to theta is going to be negative sine theta, and of course we'll multiply that by sine squared theta. Now over here we need to take the derivative d theta of sine squared theta. So let's go ahead and talk about that. So this is really sine theta squared, like that. So if we want the derivative with respect to theta of this guy, well, we treat this inside piece. We're going to use the chain rule here, so we treat this inside piece like u. So what we have is d theta of u squared. Now we can't use d theta here because we've got u as a variable here. So what we're going to do is do a replacement here. So this will be du d theta times d du of u squared. And so this is going to be du d theta times 2u du d theta. Well, if u is equal to sine theta, then the derivative of this with respect to theta is equal to cosine theta. So this is going to be cosine theta times 2 times, now u is sine theta. So this mess right here is this piece right here, okay? So we've got plus 2 sine theta cosine theta times cosine theta. This last cosine theta came from right here. So this right here will be negative sine cubed theta, because I got 2 here, 1 here, plus 2 sine theta times cosine squared theta, just like that. You typically see this one right here written with this guy in the back, so we'll probably write it like this: 2 sine theta cosine theta minus sine cubed theta. If you want to, you can factor out a sine. Some people will write it like this, and then we'd have 2 cosine theta minus sine squared theta, just like that. This last step, again, it's not really that important. It's just sometimes it's nice to be able to factor this out because you may be trying to solve some trigonometric equation, and so you might have to do it by factoring. Example part B asks us to differentiate sine 3x divided by 1 plus the cosine squared of x. Now notice that we switched from thetas to x's, so I'm going to assume that the differentiation is with respect to the variable, which is a good assumption. So what we've got is we want to take d dx of this guy. So I'm going to use my quotient rule. So this will be the bottom times the derivative of the numerator, the top, minus the top numerator times the derivative of the denominator, the bottom, all over the bottom squared. Okay, so now we need to go ahead and get these little pieces here. So this right here just comes along, so we've got 1 plus the cosine squared x. Now, the derivative of this, we're going to use the chain rule. So if you use the chain rule on this, you're going to get 3. Now the derivative of sine is cosine. Now if you're asking yourself, where did this 3 out front come from? Well, it came from the derivative of this guy right here. Let me very quickly work through that for you. If you have d dx sine 3x, and you let this guy inside here be u, then what you've got is d u dx times d du of sine u. It's chain rule right here. So du dx, the derivative of this with respect to x is 3. So that's this guy right here. D du of sine u is cosine u. And we know that u is 3x. So this is 3 cosine 3x. That's where this guy right here comes from. So this is going to be minus now sine 3x times, now the derivative of this, okay, derivative of 1, that's just 0. Okay, so this guy is 0. Now we need the derivative of cosine squared. Well, that is, we can use the chain rule again. So we need d dx of cosine x squared, which is going to be 2 cosine x times the derivative of cosine, which is negative sine. So this will be negative, I'll do it in the same color. So this is negative 2 cosine x sine x. And this whole thing is over 1 plus cosine squared x squared. Just like that. So what we're going to do, let's go ahead and continue on here. I'm going to just multiply and simplify this here. So this right here in the front gives me 3 cosine 3x plus 3 cosine 3x times cosine squared x. I can't combine these guys right here. Okay, so they're different. And then I've got plus, because it's minus and minus, so plus 2 cosine x sine x times sine 3x. Just like that. And then this is all over this mess on the bottom. And if you want to, you can factor, the book factors out a cosine 3x and a 3 out of these first guys, but that's not really anything that you need to worry yourself with. So if you want to, you can factor out this guy and this guy, and you'd be left with 1 plus cosine squared x with that guy factored out in front, but not a big deal.